Okay, yeah, very creative. Another rolling off the table problem. In this one, we know that the time it takes to hit the floor is 0.42 seconds. And checking to make sure I answered all the previous questions, all the different parts. Okay, good. All right, so on this one, we want to know how high the table is, so we basically want to know the vertical distance, sorry. We want to know this distance and the velocity when that ball hits the floor. Since we know acceleration, which is gravity, is 9.8 meters per second squared, it's pretty easy to find the final velocity, so we'll go ahead and do that one first, and then we'll deal with the distance. Since it has 0.42 seconds, where gravity is in effect, we have our delta V, and this is vertical, is equal to acceleration times that time. So 9.8 times 0.42, and we have a final velocity of 4.116 meters per second, and that is downward. Okay, so we answered that part. Right. Here it could be V final minus V initial. Just knowing that V initial is 0, we basically are finding the final velocity there. Okay, so our distance, how far does it travel? Well, we've got our initial velocity and our final velocity, so I think we go ahead and use this average velocity formula times the time, which we know. And in this case, as I'm doing these calculations, I'm thinking out loud. If you use the v naught t plus 1/2 at squared, that would be totally fine as well. I think you get the same exact answer. 0. Okay. I'm thinking about significant digits here. 0.86 meters, and over here we would go with 4.1 meters per second in the downward direction, or negative, whichever you want to do. And yeah, absolutely. If you did, like if you solve for the distance first before finding the final velocity, then just in case you want to see that, that'd be 1/2 acceleration due to gravity times time squared. The initial vertical velocity is 0, and so 0.42 squared times 1/2. Yeah, you'll get exactly the same 0.86 meters.